Example 10.4, 0 and negative exponents. All right, so let's go over our key ideas here. You know what? No, we're not going to go over a key idea yet. I'm going to show you something. I want you to tell me what this is. Write it down. I know you're going to be like, Mr. Humphreys, we've done this back in like 3rd grade. But I want you to write 5 divided by 5 down. What's 5 divided by 5? It's 1. Why? Why is that 1? Okay, let's go over to the next example. Y divided by y. What's y divided by y? It's also 1. Do you really know why? You may say to yourself, well, 5 goes into 5 one time. You're absolutely right. But let's use our rule we learned yesterday for quotients. Are these the same base? Yeah, absolutely. What are the exponents on each of them? They're 1. When we divide by the same base, what do we do with the powers? We subtract them. And 5 to the 1 minus 1 power gives you 5 to the 0. Which is exactly why any number divided by itself is 1, because your rule that you're going to learn right now is that anything to the power of 0 gives you 1. This one will be y to the 0, because 1 minus 1 is 0. So y to the 0 power is 1. Anything to the power of 0 is 1. Here's what it says. For any non-zero number a to the 0 power is equal to 1. So, for example, 4 to the power of 0 is 1. In algebraic terms, we'd say a to the 0 power is equal to 1. But a cannot be 0. So make sure you understand that the base cannot be 0. All right, negative exponents. For any integer n and any non-zero number a to the negative n power is the reciprocal of a to the n power. So using numbers, it looks like this. 4 to the negative 2 power is equal to 1 over 4 squared. Or a to the negative n power equals 1 over a to the n, where also again a cannot be 0. Now, you might not understand negative exponents yet. That's okay. We'll go over it in a little more detail with our examples. All right, for each of the following, we're just going to simplify. So if I gave you this, let's start off with negative 8.5 to the negative 4th times negative 8.5 to the 4th. What would that be? Hopefully you'd realize that those are the same base, so we're going to add the powers together, which gives us negative 8.5 to the 0, which would just give us 1. All right, B. Now, going one step further. In part B, if we had this, 3 to the 7th over 3 to the 9th. Now, we didn't do this the other day when we divided. Where are there more 3's? Now, these are the same base. Remember, these are the same base. Where are there more 3's? On the bottom. So, if you think about it, there are 7 3's on top that are going to cancel with 7 3's on bottom, which leaves 2 more 3's on the bottom. So that's why if I ask you where there are more 3's and you say on the bottom and how many more, so there's 2, therefore there's a 3 squared left on the bottom. There's nothing left on top. So it'll be 1 over 3 squared, which is 1/9. So let's take that one step further. We're going to go this way. If I subtract these, you get 3 to the negative 2 power. Your negative rule says this, that if we have 3 to the negative 2 power, it's going to flip. So it's actually going to become 1 over 3 squared, which is actually what you have right here. If that confuses you, think of it like this. Anything that you have can be put over 1 to make it a fraction. 3 to the negative 2 power is on top. We have to flip it, so it would actually go to the bottom. So then that's how 3 to the negative 2 goes on bottom. When it moves, it becomes a positive power. If that still confuses you, let's go to another example. This may help you a little more. We're going to use all letters. All right, so let's just look at this problem. A to the negative 3, b to the 4th, over c to the negative 2, d to the negative 5th. If we're looking at this, b to the 4th is the only thing that is not of a negative power, so that's going to stay the same. Anything with a negative power becomes the reciprocal. So this d to the negative 5th is going to move to the top. The c to the negative 2 is going to move to the top. The a to the negative 3 is going to move to the bottom. You do the reciprocal, they flip. And when they flip, the signs become, the powers become positive. You cannot have negative exponents in a simplified fraction. So on top, we would have c squared, d to the 5th, and then b to the 4th is going to go on the front. On the bottom, a to the 3rd. Notice that the c term, the d term, and the a term all flipped because they had negative powers. So let's do another example. D. Let's do 5x to the negative 3 power. Now, what's being taken to the negative 3 power? Only the x. Therefore, the 5 stays on top. The x to the negative 3 goes on bottom and becomes x to the 3rd. E. In parentheses, 5x to the negative 3 power. Now you are taking the 5 and the x to the negative 3 power, which means they both move to the bottom. 5x to the 3rd power. You would then take that one step further, and you would actually, I did that wrong. Notice the 3, very easy mistake to make, as I just did. The 3 has to stay outside. So we have to take 5x to the 3rd power. Well, 5 to the 3rd power is 125. And then there's a 1 here. 1 times 3 is x to the 3rd. So it would be 1 over 125 x to the 3rd. Example 2a. 7y to the 0 power. Now, what did we say? Anything to the power of 0 is what? It's 1. So guess what? This example is not 1. Why? Because the only thing taking to the power of 0 here is the y. This is really 7 times 1. Y to the 0 is 1. 7's just there. So your answer is 7. Example B. Negative 5, x to the power of 0. What would your answer be? It'd be negative 5. C. 9 y to the 3rd divided by, let's do, let's make it negative 3rd power over y to the 5th. Now I'm going to show you both ways to do this problem. Way number 1 is this. You would take 9, y, same base, we're dividing with the same base, so what do you do with the powers? You subtract them, so negative 3 minus 5. That would then give you 9y to the negative 8th power. The 9 stays on top, the y to the negative 8th goes on bottom and becomes y to the 8th. Here's what I suggest you do, because to me this is easier. Do you notice on top here, you have a y to the negative 3. Because it's negative, it goes on bottom and becomes y to the third. What's y to the fifth times y to the third? Same base, what do you do with your powers? You add them, so you have 8. Or you can think of it this way. Y to the negative third goes on the bottom. There's already 5 y's here. You're adding 3 more to it. So therefore we get a y to the 8th on bottom. However you want to do that is completely up to you. Let's do another example. D. Z to the 6th over 15z to the 9th. So where are there more z's? There are how many more z's on the bottom? 3. So you're going to get 15 z to the third on bottom. So your answer is 1 divided by 15z to the third. And once again, if you wanted to do this, you could do this. This would be 1, and then you'd have, oh, let me erase that here. You could do it this way. 1/15 times z to the negative 3, because 6 minus 3 is, or sorry, 6 minus 9 is negative 3. And then you take the reciprocal of this and you get this on bottom. To me, this is way too much work. I would just look at this and say, where are there more z's? On the bottom. How many more on the bottom? There are 3 more, so therefore you have z to the third on the bottom. Example number 3. A drop of water leaks from a faucet every second. How many liters of water leak from the faucet in 1 hour? A drop, and that should say of water. All right, so of water is 50 to the negative 2 liters. So we have to first convert 1 hour to seconds. So if we have 1 hour, we know that there are 60 minutes in 1 hour. We also know that there are 60 seconds in 1 minute. Whoops, let me get that right here. So minute. So hours cancel, minutes cancel. So that gives me 60 times 60, which is 3,600 seconds, which would be in an hour. So water leaks from the faucet at a rate of 50 to the negative 2 liters per second. So we have to multiply that by the rate. So we should take 3,600 seconds times 50 to the negative 2 power, which is liters per second. So we're just taking 3,600 times, now 50 to the negative 2 power, we flip it. It becomes 50 squared on bottom, 1 over 50 squared, which gives us 3,600 times 1 over 2,500, which gives us 3,600 divided by 2,500, which is equal to 1 and 11/25, which is equal to 1.44 liters. So 1.44 liters of water leaked from the faucet in 1 hour. You didn't think we were done yet, did you? Good, didn't think so. So we're going to put everything together into one problem. You're going to love this. This is so much fun. So, A, I want you to put 5x squared times 2x to the third divided by 2x all to the negative 3 power. Now you're like, what in the world are we doing here? Just take it one step at a time. I'm going to start in parentheses. Now once again, there are multiple ways to do this. So everything to the negative 3rd power to me, I'm not even going to do. So first off, I have 5x squared. That just comes down. I then have to take 2x to the 3rd power. Notice that the 2 here is on the inside, so there's nothing I have to take to the 2nd power. Here, I have to take the 2 to the 3rd power and the x. So 2x to the 3rd power gives me 8x to the 3rd power. the bottom stays the same. So then I get 40 x to the fifth over 2x, all to the negative third power. I then can simplify, and 40 divided by 2 is 20, x to the power 4 to the negative third power. I then have to flip everything. That becomes 1 over 20 x to the fourth to the third, which then gives me 1 over 20 times 20, which is 400, and 400 times 20 is what? Good. It's 8,000. And then I multiply my powers, x to the 12th. So you would get 1 over 8,000 x to the 12th. Example B, 7m to the negative third, n to the negative second, p to the fourth, all divided by 49, m to the third, n to the negative fifth, p to the negative 2. The first thing I will do is I will simplify 7/49. That would be 1/7. I then go and let's start simplifying. So I have m to the negative 3, which is going to move down. There's already 3 on the bottom. So if there's already 3 on the bottom, that's going to give me on the bottom m to the 6th. Then n to the negative 2 goes to the bottom, m to the negative 5th goes to the top. And when they do that, they become positive. So n to the 5th becomes on top, and n squared is on bottom. I then have to take my p to the negative 2, which is on bottom, and move it to the top. Because there's already 4 on top, I combine it and I get p to the 6th. Are you done? No. I can simplify my n's. Where are there more n's? There are 3 more n's on top. 5 minus 2 is 3. So my answer would be n to the third, p to the 6th, divided by 7, m to the 6th. We don't even need that 1 there. And that would be my answer. Once again, this can get confusing. And if you were a little confused, that's okay. We will keep working on these problems and keep doing them. And please ask questions if you don't understand something.